can a hypothesis be tested by the realism of its assumptions? And now this topic was already started in section 2, and now he makes it in greater detail by presenting 4 examples, which have been widely discussed in the literature. And at first he starts from physics and says, look, in physics, people use the law of free fall. The law of free fall is valid in a vacuum. That means S is a half gt square. S is the distance, fall distance, g constant of gravitation on Earth, and t is time. And so you can calculate S, the dependent variable, as a function of time. So you can tell after 1 second, after 2 seconds, what the distance is. And now the point is this. When this law is applied in a situation without vacuum, this is a law that holds in vacuum, because if you don't have vacuum, you've got friction, right? And the friction changes, of course, everything. When applied in a situation without vacuum, law is good for a falling ball for short distances and bad for a falling feather, right? It doesn't work for a falling feather, and is bad for a falling ball from high altitude, or for a jumper, right? Because after a while, maximum velocity is 300 kilometers per hour, and then it's constant due to friction. Okay, so this is a law with limited validity. And then he says, well, if these people who say we want to test a law by its assumptions, what would that mean? It would mean, is the actual air pressure close enough to 0? Right? If you apply that law in a concrete situation here, and I won't do it, but if I have a heavy body and it falls down, then the law of gravitation, I'm using it here, although there is friction. And there he says, this question, whether here, for instance, for 1 meter of fall, whether the air pressure can be neglected, can be put to 0, that's only answerable by investigating whether the formula gives good predictions for specific situations. So the question, you cannot ask abstractly, well, is the air pressure close enough to 0? You can only do that by trying out, let this thing fall, measure it, and then you find out whether the law of free fall describes that properly or not. If it doesn't, then you see, okay, therefore the air pressure must be deviating enough from 0. So he says, to test this assumption, you must test the predictions, and there is no other way, right? And he tries to describe that, or explain that, or certify that by this assumption, right? And the assumption illustrates, according to Friedman, the impossibility of testing a theory by its assumptions, right? By looking at the assumptions, are they good assumptions, are they bad assumptions? And then I get an opinion on the validity of the theory. No, the inapplicability of a theory for special cases is only revealed by bad predictions. And an independent test of the assumptions is impossible. Right? And the assumption here is, as I said, it's air pressure. Is it close enough to 0 to apply the law of free fall? And there he says, look, the only way to test it is by the predictions. You cannot directly test that because you don't know what it means to say close enough to 0. What is it? 1, 100, 10 to the minus 15? Okay. And then he says, furthermore, an ambiguity in the expression assumption of a theory, and I'll come back in great detail to this terminology here. The successful cases of the application of law of free fall show that in these cases, the bodies fall as if there was a vacuum. The assumption is something that describes an as-if situation. And that is somehow, this is strange. It's not what we usually mean by assumptions. I will come back to that. Whereas in economics, this would be translated into the theory assumes a vacuum. So he says economists assume, for instance, or make, the assumptions of Homo economicus. And then they say, economists assume Homo economicus. And he says, look, this is a very strange way of talking, because it's not clear that you assume that this is true. It may only mean that people behave as if they were Homo economicus, and that's a difference. And this is what he means. There's an ambiguity in the expression assumptions of a theory, how economists talk. And this is very important, and we see that later. This is really the substance of the article. That's very important. And this is not the case. It's only stated that for some situation, the only relevant variable is gravitational force. So if I'm using the 0 air pressure in this situation, vacuum, I'm only saying, look, here with 1 meter, perhaps 10 meters, that works fine. But I'm not saying what happens if I take 2 kilometers, right? And with a base jumper jumping out of a plane, right? There I say, no, wait a minute. So I can only say for some situations it's a good assumption, a good approximation, all right? So here's the second example, an analog of many hypotheses in the social sciences. So the first example, this is threefold, is fairly transparent, one fairly well understands, but it's the simplest one. And now come examples that are not so easy to understand. Consider the density of leaves around a tree, which is not a typical economic question, right? So, but there is the fact that apparently that the leaves are denser at the south side of trees than the north side. I mean, there's more sun. Okay, and the question is, how can we explain that? Now, there he says, let's introduce a hypothesis H star. Leaves behave as if they individually calculated maximally receivable sunlight and moved accordingly. So you describe that tree, of course, counterfactually, as if the individual leaf calculated, where should I sit, right, in order to receive maximal sunlight. And then he says that hypothesis explains how the leaves are distributed on this tree, right? That may be empirically right, I don't know it. And what he says is then some consequences of H star are consistent with experience. For example, that leaves are usually denser on the south side of a tree. So this is a massively counterfactual assumption, but the assumption explains something that's found in reality, although it's deeply false, of course. I mean, the leaves don't move at all, nothing. So this is really deeply false, wildly non-realistic. So H star is obviously false, but has great plausibility. This is what he says. I don't think he means plausibility. I mean validity anyway, but I don't want to quarrel here. Because of the conformity of its implications with observation. So he says, look, although this is deeply false, but it explains certain things, or describes or predicts certain things of how leaves are distributed on a tree. And therefore it's interesting, right? Has great plausibility, validity, whatever. Okay. And the validity of that H star may be explained by showing that its consequences are the same as those of a much more realistic hypothesis H, embodying passive adaptation of the leaves. So if you use biology and describe why are the leaves optimally distributed on a tree, then you have selection theory, and those trees who are better in distributing their leaves are then have a differential selective advantage, and in the longer run, those are the trees that survive. But the point is that H star treats the trees completely differently, but the result is the same. Right? The result concerning empirical predictions is the same. And H, the true hypothesis, I mean, why is it that the trees are there, is to be preferred not because of its higher realisticness, but it's part of a highly confirmed, more encompassing theory, namely the theory of evolution. Right? The theory of evolution tells you basically what the structure then of trees is, and which that theory of evolution supports H. Now, if you look at that, then you may say, yes, it's somehow plausible, but it's not completely transparent what's going on here. And this is so, and later I'll come to that in greater detail. So he says H star is only valid for a class of very special situations, very special about these trees, and possibly only for certain classes of trees, but not for all trees, but it works there. However, this class and its defining parameters cannot be determined by analyzing H star. So this example may leave one in a state of slight confusion. I mean, what is he really trying to say, right? So, okay. Well, here is the third example, and that's again a little more transparent. He speaks about an expert billiard player, and she behaves as if she calculated the trajectories of the billiard balls on the basis of the laws of physics. So these are differential equations that you have to solve. So the expert billiard player, it reflects 3 times and then does this or that. And the expert billiard player, this is how he says, behaves as if she calculated the trajectories, right? So if you calculate the trajectories, then you come to this solution. You've got to push it in this way. This counterfactual hypothesis would give excellent predictive results concerning the shots performed by the expert player. So if you ask a physicist, calculate please what would be the best shot, then the result is very much the same as that of an expert player, because they simply know somehow the optimal solution. Now, this is a short step now to example 4. Again, what do we learn from this? He said, well, in a sense, I can predict the behavior of the expert player by the differential equations, right? But the expert player is usually not a mathematician, and she knows it somewhere else. But somehow the results are equivalent, okay? What do we learn from that for economics? Difficult to say. Let's see. Okay, and then he says it's a short step to example 4, and now we are back to economics. In a wide range of circumstances, firms behave as if they rationally maximize their expected returns on the basis of full information, right? That is what economists would do. They say, okay, what's the expected returns on the basis of full explanation when they rationally maximize, and you assume that the firms are rational, like the other players in the market, and firms behave as if they do it, right? So like the expert player, she behaves as if she calculated. She doesn't. And here he says, firms behave as if they did that, but they don't. But it's the same as a result, okay? And the confidence in this counterfactual hypothesis about the behavior of firms is not by empirical investigation of the behavior of the businessman or of the expert billiard player. You do not do that. You don't empirically investigate in order to come to this conclusion. If firms behaved not equivalently to the rational behavior, they would be wiped out by natural selection. Right? You say, I can replace their actual behavior and their strategies to find out what to do by this rational calculation assumption, although I know it's false. But the point is, this is what's giving the right behavior if that firm has survived on the market. Right? And it would have been wiped out if they didn't optimize, because then others would have found a better strategy and the firm would, in the long run, be wiped out. And most importantly, he says, for this counterfactual hypothesis, countless applications to specific problems and implications of the hypothesis are not contradicted by experience. So it's fruitful. You can apply it in many situations, not in all situations, but in many situations. And because it's fruitful there, it gives the right predictions. We are using it in economics. And no widely accepted alternative exists. A more realistic doesn't exist, so therefore we are using it. Okay, this is what he said. So the result is, in the examples, the assumptions of hypotheses are intentionally counterfactual. Economists know that, and are as such incapable of being of a direct empirical test. Right? If I know that the firm owners or the management does not calculate, it doesn't make sense to test it whether they calculate. I know that they don't do it, right? But I replace their real behavior by this behavior because the predictions that we are getting are the right predictions. This is what he claims, right? Still, if there's still some fog in your head, that's right, there is some fog, and it's not really understandable. Okay. So the next step then in his article is the significance and role of the assumptions of a theory. Assumptions of a theory play 3 different roles, he claims, and he does that in different subsections. The economic mode of describing or presenting a theory, the economical mode of describing it. So it's one way to present a theory by referring to the assumptions, to facilitate an indirect test of the hypothesis by its implications, and specifying the conditions under which the theory is expected to be valid. Okay, let's go to these sub-units here. The use of assumptions in stating a theory, and there he says that a hypothesis may be capable of summarizing many different situations by using an assumption. So it's an economical way of describing something. Example, the counterfactual hypothesis about the distribution of leaves on a tree summarizes many different situations. This is what he claims. So you have this counterfactual, and then you can many different aspects of many different trees can be summarized in this hypothesis. So as a descriptive hypothesis, it's something that's useful. And more generally, the hypothesis or theory asserts certain forces to be important for a certain class of phenomena, and by implications other to be negligible, and the mode of operation. So the hypothesis directs your attention to something and says, this is the important factor in this or that situation.
Sorry, I don't understand what a counterfactual hypothesis is.
Well, it's their assumptions, right? They count in that case of the leaves, that every individual leaves try to optimize its plates on the tree. That's the counterfactual assumption. Or that the management calculates really the marginal costs and marginal utility when they ask whether they should increase production or not.
Counterfactual hypothesis is built by this counterfactual assumption.
It is, yes. The counterfactual means it's against the facts. If I counterfactually assume that here are 1,000 people in this lecture hall, then this is a counterfact because the facts are different, right? So it's counterfactual. And the assumption that the management calculates that is counterfactual. The assumption that the trees that the leaves individually decide is counterfactual. So there's a counterfactual. They are false. This is what he says. They are intentionally false, counterfactual, right? Not realistic. So, but the point is that by these assumptions, certain forces are important, and that consists of 2 points. Abstract, the part 1 is an abstract model of the world, simpler than the real world by containing only forces asserted to be relevant. So that's the same, by the way, with the free fall. You say, oh, for that case, if it's only these small distances and it's a heavy body, then the most important thing is gravitational force. Forget everything else, right? And this is what he says, that this is important. The model itself has no vagueness or approximation. It's abstract and complete, meaning air pressure, and the model itself, so for the case of free fall, is simply the law of free fall. That's all that's relevant. Everything else has been abstracted away. So it's very clear. It's no vagueness. It's a very clear situation. And the second part is then a set of rules defining for which phenomena the model is intended and establishing correspondence between the model and the world. So you have, for instance, in the law of free fall, you have to say, look, these are the situations where you can use it, and for those situations you can't use it. So don't use, when you ask how long does it take a feather to reach the floor from here, don't use the law of free fall. It doesn't work there, right? So it gives you something, rules defining the correspondence between model and world. And these rules, he says, must be incomplete because of the openness of the set of applications. They are not completely sharp, leaving room for judgment. And there it's an interesting side remark, can be learned in the right scientific atmosphere. What he's saying there, if you do graduate work or postdoctoral work, go to a good institute. There you learn how to play around. They cannot be written up completely explicitly. You learn it by practice, learning by doing in science. And he's right there, I think. Okay. A simple example is Euclidean geometry. When you use it for real cases, it's an abstract, purely mathematical model, mathematical geometry. And if you use that in real space, then you have to identify physical things with geometrical objects, and they cannot be completely described by rules. That's what today is called physical geometry. In economics, crucial assumptions are the key elements of the abstract model, that's what he claims. And although the model itself can be described in many equivalent ways, axioms and theorems can change place. Crucial assumptions are singled out for practical purposes. Well, if one asks what exactly is he saying there, well, what he says there, look, there are these assumptions, crucial assumptions, they are counterfactual, and they play a major role. Right? Much more you can't get out of it. Then the use of assumption as an indirect test of theory, well, I skipped that. I've never understood that section, and it doesn't play a role.